So we are going to continue our discussions of chapter number 1, which is number systems. And now in this video, we are going to answer an important question, which is what are irrational numbers? Okay. So far we have seen uh, natural numbers, then we have seen whole numbers, then we have seen integers, and then we have seen rational numbers. Now there's another set of numbers which is called as irrational numbers. So let's see what does it mean. Okay. So here let's read out the description. Okay. A number, what's an irrational number? It's a number that cannot be written in the form of P by Q. That is, irrational numbers are numbers that are not rational numbers. Quite a simple and straightforward definition. Basically, these are numbers which are not rational numbers. Okay, what does that mean? It cannot be written in the form of P by Q. As simple as that. That's the definition of an irrational number. It is not a rational number. It cannot be represented, it cannot be written in this form of P by Q. Now, let us see some examples of irrational numbers. So once again, I'm going to get rid of this. Yeah. So these are the examples of irrational numbers: under root of 2, under root of 3, square root of 5, square root of 6, square root of 7, so on. There are many, in fact, there are infinite irrational numbers. So as you can see, these numbers, for example, I have written down the decimal value of square root of 2 and square root of 3. So you can see square root of 2 is 1.41421356 dot dot dot. Now, this dot 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 is very important. This dot 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 means that there are more infinite numbers in this decimal expansion of square root of 2. I have just noted down first 7, 8 numbers. Same goes with square root of 3. Its value is 1.73205080 dot dot dot. This indicates there are infinite more digits in this decimal expansion. Same is the case with square root of 5, square root of 6, square root of 7. Basically, the point is that these numbers, okay, these numbers, they cannot be represented in the form of P by Q. They cannot be represented in the form of P by Q. Hence, they are classic examples of irrational numbers. Now, let us move ahead and try to understand the representation of irrational numbers using a Venn diagram. Okay, so we are going to try to plot the Venn diagram, okay, of natural numbers, whole numbers, integers, and rational numbers. First, let's do these 4 set of numbers, and then we'll see how irrational numbers come into the picture. So let's quickly note down what are natural numbers. So natural numbers, as we know, are 1, 2, 3 dot dot dot. Then whole numbers is nothing but to add 0, and that is 1, 2, 3 dot dot dot. And then integers, as we know, we add the negative numbers. So it's -2, -1, 0, 1, 2 dot 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 on the right hand side, and dot 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 even on the left hand side. Okay, so first let's represent these 3 set of numbers using a Venn diagram. Now, okay, so let's say if this small rectangle is a natural number, okay, then if you add 0 to it, this becomes a set of a whole numbers. Okay, and then additionally, if you add the negative numbers, this becomes our set of integers. Okay, so in fact, I'm going to give the names. So yes, so this is our natural numbers. So I'm going to write here natural numbers. Okay, then this thing, so this is whole numbers, so whole numbers. Okay, and finally we have our integers. Yes, so these are integers. Okay, so natural numbers, whole numbers, and integers. Now we all know that these 3 set of numbers can be represented in the form of P by Q. So that is the classic definition of rational numbers. Rational numbers, any number which can be represented in the form of P by Q, where Q is not equal to 0. That's the only condition. Okay. For example, let's come down. Okay. So all the natural numbers, or in fact, all these natural numbers, whole numbers, and integers. Now, for example, let's take a natural number 5. So it can be represented in the form of p by q if you divide it by 1. Okay. Same goes with whole numbers. Take any whole number, let's say 0. If you just write 0 divided by 1, that's a rational number. And you go with any integers, even if you take minus 5, and if you write minus 5 divided by 1, that is also a rational number. Which means that rational number is going to be a bigger set. Okay. So rational number is going to be a bigger set in this set of Venn diagrams. So I'm going to use a different color for yes, for rational numbers. So rational numbers is going to be something like this. Yes, this is a bigger set of a rational number because it will consist of all these three sets. Okay, and it also consists certain numbers of its own. For example, 1 by 2, 1 by 3, 1 by 4. They are also part of rational numbers. So okay, let's just give this name. So we have now rational numbers here. Rational numbers. Okay. So this becomes a Venn diagram representation of all these four set of numbers in our number system. Now the important point is the new set of numbers that we just saw, which is irrational numbers, cannot be part of this red box. It cannot come inside this red box at all. We have to draw a separate box for it and call that as an irrational number. Why? Because that is the very basic definition and that is the exact definition of an irrational number. A number which is not a rational number, which means it will have its own separate box. So let's come down. Now, a set of all these rational numbers and all the irrational numbers is actually called as real numbers. So, yes. So what are real numbers? Real numbers are nothing but set of rational plus irrational numbers. Set of rational plus irrational numbers is called as real number. So if I want to plot real numbers on a Venn diagram, so I'll show you how it can be done. Let us make a copy of this. Copy. Okay, let's paste it here. Let's make it. Yes. Okay. So these are all our. Okay. We know these are all. This is the whole. The red box is the whole set of rational numbers. Now to represent irrational numbers, let's take a different color. Yes. So irrational number will be a different box itself. So I'm going to just make another box here. This is my irrational numbers. Let me write it inside it. Or okay, let me write like this. These are my irrational numbers. Okay, and these rational numbers plus these irrational numbers will be the box of real numbers. So again, this is a different color. Let's go for violet. So this bigger box of real numbers, it will be like this. Okay, and this box I'm going to call as, very important, these are my real numbers. Okay, let's zoom out. Yes, these are my real numbers. So once again, just to go through what is the definition of real numbers. It's a set. Real numbers is a set of both rational and irrational numbers. So these are my rational numbers. Obviously rational numbers also include all the integers, the blue one, all the whole numbers, the orange one, all the natural numbers, the black one. So these rational numbers and this, in fact, let's use this to write it here. So these are rational numbers, the red box. Yes, the red box is a rational number and this is a irrational number, and the set of both of these becomes our real numbers. Okay, now there's an important point that we have to note about real numbers, and this is that a number line has all the real numbers present on it. So all the real numbers that are present in the number system can be represented on a number line. So if you draw a number line, we know number line from our previous discussions. So a number line is okay. Okay, this is our number line. So let me try to zoom in. Okay, So this is 0, this is 1, this is 2, this is -1, this is -2. Okay, so clearly we have all the integers, whole numbers, and even uh, let's say now let's plot an irrational number. Okay, let's go with this will be my irrational number here, -1/2. Okay, sorry, a rational number. This will be my rational number here, -1/2, or this will be my another rational number here, 1/2. Now, what does the note say? The note says that it also, your number line, this number line also has all the real numbers, which means it will also have all the irrational numbers. Okay. For example, let's try to plot root 2, the value of square root of 2 on this number line. So let's go up and see what was root 2. Root 2 was 1.41, so it was something like 1.4. So if I go here, so 1.4 will be roughly somewhere here. Okay, so this is roughly is our square root of 2. Okay, similarly if you go with square root of 3, let's zoom out. Yes, so square root of 3 is 1.7. so where can I plot square root of 3? Let's zoom in. 1.7, so it's roughly going to be somewhere here. Okay, this will be our square root of 3. Okay, so thus a number line will have all the real numbers, which means it will have both the rational numbers and the irrational numbers. That's all about this video. This was an introductory video on irrational numbers. What exactly are irrational numbers? In the upcoming videos, we will see how to plot or how to locate irrational numbers on a number line.